Okay, so in this video, I'm going to talk through the calculations that go along with this lab that's going to be essentially the quiz. And so you'll be doing these calculations on your own. Last time we had class, we gathered all the data. And so we got all the data that we need to be able to run this lab. And if you're not going to be here next class where we go through this again as your quiz, then please find a time to come in, and I'm going to give you fictitious numbers, and then you're going to continue to do the lab from there. So we have the mass of the metal, which when you do the quiz, this number will be different. Like these numbers will be different for you. The mass of the water, the specific heat of the water, the temperature initial of the water, the temperature initial of the metal, the temperature initial of the water, and then this is both the final temperature of the water and the metal. Now, what we're going to need is a delta T, is a change in temperature. And this is going to be for the metal, and it's also going to be for the water. Okay. Delta T for the water. Now, reminder, this delta T is final minus initial. So what is the final temperature for the metal minus the initial temperature for the metal? This is the final temperature for both the metal and the water. And so if I take that final temperature, 28.2, and your number could be different than mine, and I minus it from the initial temperature, then this is the overall change in temperature. So I'm getting a negative 71.8. And the degrees Celsius stays the same. So that would be degrees Celsius. Same thing for the water now, but the water is going to be a positive because it increased in temperature. So this is my final and this is my initial. So if I do my 28.2 and I minus it from the 24, then I increased by 4.2 degrees Celsius. Okay, so that information is going to be really helpful in calculating the specific heat. And so here's how we do this. I'm going to use the following equation 2 times. Q is equal to mc delta T. Q is the heat that's gained or lost, M is the mass of the item, C is the specific heat, and then the change in temperature. So I want to calculate the heat gained by the water here, so I'm solving for Q. I need the mass of the water, I need the specific heat of the water, and I need the change in temperature of the water. But the good news is I have all of those things. So back on that data table, I know that my mass was 200 grams for the water. I know my specific heat was 4.2 joules per gram degrees Celsius. And then we just got our change in temperature for the water, which was also, interestingly, 4.2. Yeah, 4.2 degrees Celsius. Now yours might be different than that. So just keep in mind, those are not always, and they're usually not the same number value. So plugging this into the equation, M times by C times by delta T, I take that mass, I times it by the specific heat, I times it by the change in temperature, and this is my energy that was gained, 3,528, and then energy is measured in joules. So you're going to need to remember the units that go along with that for the quiz. So the water gained this many joules of energy. Determine the heat lost by the metal. Well, reminder, we had our white styrofoam cup, and there was water inside that cup. That's what we're talking about, that water. And then we put a metal cube inside of that water. And that metal cube was way hotter than the water that was in the cup. And so there was heat that was lost by the metal and gained by the water. But what's really cool is the magnitude of that heat that was lost by the metal is equal to the heat that was gained by the water. And we know how much heat was gained by the water. So it's got to be the exact same number that was lost by the metal, but it's a negative because it was lost, it was released. So the heat of the metal is a negative 3,528 joules. So when you do the quiz, it's the same amount of heat calculated for the water, it's just a negative. And then the last part of this, we're going to find the specific heat of the metal. So here's all the different parts of this equation. We have the heat of the metal, the mass of the metal, the specific heat of the metal, and the change in temperature of the metal. We're trying to find the specific heat. So we know that the heat released by that metal was negative 3,528 joules. We know that the mass of the metal, which from our data table, my data table said 120.74, 74 grams. We're solving for the specific heat, and then the change in temperature, again, we got that delta T of the metal, so negative 71.8 degrees Celsius. So this number, really all of these numbers could be different for your values depending on what you had and which cube you were given. And the equation is Q equals mc delta T. So if I divide by the mass and delta T, then that isolates the specific heat. So like divide both sides by m delta T, and then now specific heat is isolated. So last step is plugging this in my calculator. Please be careful. Make sure you include all the negative signs, and we put parentheses around our values in the denominator there. So I would do negative 3,528 divided by, open parentheses, the mass, 120.74, times by the delta T, negative 71.8. Those double negatives should always cancel to give you a positive value, and I'm getting a positive value of 0.407. For this lab, we're not going to look at sig figs because there's a lot of adding and subtracting, so it's kind of hard to keep track, and instead I'm going to just ask that you give me 3 digits after the decimal, and so we're going to have 0.407. Now the units of specific heat are joules divided by grams multiplied by degrees Celsius. This makes sense because heat was in joules, and we're dividing it by mass, which was in grams, and that's multiplied by delta T, which was degrees Celsius, and that's our final answer. And so depending on the specific heat that you get, I'm going to compare it to the actual specific heat of these different metals, and then we're going to see how close you are, and that's what your quiz is going to be. So we're going to head back into the lab. You're going to gather all of this data for a different metal cube than you had before, and then you're going to calculate the specific heat of this new cube, and I'm going to have a list of all the different metals that it could have been and compare it to your answer to see how close you were. If you have any questions or concerns, please feel free to email me. If you're not going to be here to do that lab, make sure you stop by when you can so I can give you these papers and fill in the numbers at the front for you. And you can still do this as a quiz. Okay? All right, thank you.